Well, this was the other power supply. I've managed to get into it. This was the case. I just used a little spudger tool, which I use for car removal, and just caught a corner and lifted it up. You can see cracked one of the posts off there, but the others are okay. That one lifted up, that one stayed in the pot, and so did these ones. So not unsurprising that they broke off. Interesting results. So let's bring the multimeter in. You can see the multimeter taking the spur off the winding of the actual transformer. This should be the feed, which is the 10-volt feed, which would go straight off to the Commodore. Let's turn the power on. And this is the results. So it's giving out 11.56 volts at that point. And a bit of a budget job for the fuse at the end here as well. Potting material is very different from the other potting material, but I can actually see the voltage regulator under there as well. So that's fairly exposed. So let me just plug it into the feed from the windings up here, and you can also see then what the voltages are there. Okay, so these are the other legs. They're feeding now the bridge rectifier circuit, which will be underneath there, the capacitor, and then the voltage regulator. So turn the power on. And a slightly different result. That's 11.8 volts. I guess that the lead capacitance on the other end of that cable is having some impact on the other voltage output, because I would have expected those to come back up. Interestingly, it's crept up to, well, it's still at about 11 volts. So let's look at the other side of the regulator, which will be these two pins here, and we'll have a quick look at those. Okay, we're now connected to the output from the voltage regulator. Let's have a look at what that voltage is when we turn the power supply on. So we're up around about 6 volts, which I think I've read up everywhere is not a good voltage for the Commodore 64 to see. What I may try and do, as I can get to the legs, I may try and actually get to the side of the voltage regulator just to see what it thinks it's pushing out, and see if that's any clearer from there. So this is a very interesting circuit. I've not seen this one on YouTube. We have the bridge rectifier diodes as a package. Still the same 4,700 microfarad capacitor, and a variety of resistors, and then probably a tantalum capacitor as well. They can go bad as well, so I may have a look at that one. The inside, here's the look of the inside. So as you can see, there's the rectifier, and I will test to see if it's going bad at all, but the rest of it came out fairly easily. So these are the windings from the transformer itself. I'm going to change this. You can unslide it. I mean, this just slides out, so I'll be able to slide this out and take the old fuse packaging and then replace the fuse packaging if I want to. But I am going to order a brand new power supply anyway, just to have that. But I thought I'd add a video on this particular transformer, as it's an old brick style and slightly different potting material, and help others who are looking to rescue these power supplies maybe.